going to move straight on to the next speaker, David Mindell. Can I have some sound, please? David Mindell, from also from Aeroastro, but his topic here is towards situated autonomy. He's also an entrepreneur himself. Very recently launched a company, Humatics. So I think David is ready.
Happy to be here today. Always feel a special link to ILP because my first exposure to MIT was when I was 14 years old and I came to an event like this with my dad at what was then the Architecture Machine Group and then became the Media Lab. So ILP as a high school student was my way into MIT, where I've been for the last 25 years. I talk today about what I call situated autonomy. How do we take autonomous systems and embed them in various different kinds of human systems? The company is Humatics. It's misspelled in your program, and it was founded in 2015, not 2014, as is described in the program. First four letters of human, last four letters of robotics with human first. That's the way to remember it. Over the last 10 years, I wrote two different books. One is about the computers and the software that was built here at MIT for the lunar landing. And that system originally was envisioned as a fully autonomous system with two buttons. One button that said, "Take me to moon," and one button that said, "Take me home." And what you ended up with as it actually came into operations was the system that's pictured on the cover here was very, very rich, very well engineered, very flexible, semi-autonomous system that the astronauts were capable of changing the modes in response to the environment. The book I wrote last year, Our Robots Ourselves, Robotics and the Myths of Autonomy, very much on the theme of what we heard in the previous talk. Very few systems, really no systems that we operate today are fully autonomous. There's always a wrapper of human intention and design in order to make the thing useful. How do we think about, what have we learned from the deep ocean, where I spent a lot of my career, aerospace, spaceflight, aviation, about operating autonomous systems, semi-autonomous systems in those environments that are useful as ways of thinking about designing situated autonomy as we move forward. Think about driverless cars in cities. Much more challenging problem than the DARPA challenges out in the desert. The end of that book really opens the question, okay, so these are some big ideas. How do we actually think about engineering systems to actually do this? What are some key technologies we'll need? And that's where I founded this company about a year and a half ago called Humatics. And our first foray into this realm is called microlocation. Think millimeter scale GPS-like tracking in local environments. And I'm going to ask them to play a video which will give you a little thought piece and I think make clear both the aerospace and the industrial parts of it. So let's run the video.
What does it mean to be on the cusp of microlocation? It means a new frontier of human-centered design, synchronizing modern technology to create a symphony of applications. Microlocation will drive our next era of data, mapping movements to absolute precision, down to the width of a single hair. Unlocking potential with small, inexpensive sensors. Ubiquitous, functional indoors, outdoors, day or night, in all weather. Harnessing the imperceptible complexities of movement between human and machine, allowing us to remain connected, relevant, active participants in a technological world created for us, ready to construct, collaborate, explore, engage. The opus of our movements, captured by microlocation, becomes second nature. Imagine the possibilities.
So that video is really suggestive as much as anything else. I'll tell you a little bit more in concrete terms. What can you actually do when you can track people, places, and things relative to each other at the millimeter scale? I Founded the company with my colleague Gary Cohen, who's actually an intellectual property lawyer, so we've been filing IP like crazy. And our CTO is Greg Sharvat, who is the young visionary in small and short-range radar systems. In fact, he wrote the only book on the topic about 2 years ago. Comes out of Lincoln Labs and a bunch of other startups. Although this technology is actually based on a type of sonar technology that I built with the Woods Hole group over about 20 years, doing this very, very similar millimeter scale tracking in the undersea world. So we've been through a lot of the navigation software problems as well. And frankly, radar and RF millimeter wave is a much better modality than sonar for it. And James Kinsey just joined us out of Woods Hole, actually, as our chief robotics officer, who's done a lot of that undersea mapping work based on those technologies. Again, the board reflects our aerospace roots as well as the undersea roots. We have 2 founding advisors, people who have mentored me for more than a decade. Bob Ballard, the founder of the Titanic, who I worked for 15 years at Woods Hole, and Dave Scott, MIT graduate, worked on the Apollo computer, and 7th person to walk on the moon, but 1st person to drive on the moon. Our corporate board includes Tom Lee, who is really the guru of CMOS RF out at Stanford. Ray Stata, you may know as founder of Analog Devices. Steve Holtzman, CEO currently of Decibel Therapeutics, former CEO of some of the big pharma startups in town, very, very familiar with licensing in multiple verticals at once. And Frank Moss, also a great MIT connection, started his career at Draper doing inertial night guidance and ended up founding a whole bunch of startups as well. I'll give you a little bit more. There's a lot of verticals that we're working in, and I picked a couple that are the most aerospace relevant, although I didn't include the manufacturing one, but I can talk about it. You think about problems like drone delivery. Other people obviously are thinking hard about that and putting a lot of money in it. The last 100 feet is a real challenge, whether it's airborne or ground-based. Obviously, GPS won't get you there, but vision-type systems are actually pretty challenged in terms of weather conditions and whatnot. Similarly, human motion tracking, the body. These are expensive Vicon systems. They're the kind of province of high-end MIT labs. My colleagues have them. Big physiology labs, but they're not out in the world in any meaningful way. They're still too light sensitive, very expensive. Our goal is partly to democratize motion capture. And also connected home, which I didn't say too much about, but a lot of people interested in different new kinds of applications in the home. We aim to provide a local but very highly precise, high-speed coordinate frame for a lot of the new applications that people are thinking about, robotics in the home, but other types of applications as well. Frankly, our biggest problem as a startup has been rank ordering these verticals and choosing the directions to go and making a business strategy that could cover the most of them at once with our technology development and figuring out where to go first. We are, as I mentioned, we've done some real breakthrough work in microwave technology. We're very much at the cutting edge of millimeter wave in integrated circuits, which is really key for a lot of different Internet of Things type applications. And we're very much at the high end there of what's possible, although with actually very traditional, a lot of innovative stuff with very traditional semiconductor processes. So our costs are going to be super, super low. Sort of thing we can do with a drone type application. Again, measure millimeter scale distances, put 4 of those together and to one point on the ground. We actually filed IP on this particular problem. Very, very good for a kind of docking application. And again, we did this undersea in the 90s. Now it's just a challenge of adapting some of that technique to the different time constants in physics we're dealing with. And I'll leave you with this kind of image of a kind of connected home application for, we're really just beginning to explore the space of what can you do when you have a millimeter scale coordinate frame throughout a home. And we never expect to build the robots that move around in there, but the people who are building those robots are awfully interested in this question.